Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the energy of a photon and the energy per mole of photons for radiation of wavelength 600 nanometer red, 550 nanometer yellow, and 400 nanometer blue. So we're supposed to calculate the energy of a photon and the energy per mole of photons for each one of these wavelengths. So we're going to start with, of course, number one, which is 600 nanometer. By the way, for those of you who don't know, this question is from the Atkins Physical Chemistry 11th edition textbook from chapter 7. So for those of you studying quantum chemistry or quantum mechanics, this video is right up your alley. Anyway, so the first thing you have to know is that we're told to find the energy of a photon, which we usually denote as change in E. And then we're told to find the energy per mole of photons, which is just E um sub mole. Okay, so E mole. So that's what we're supposed to do. So that was supposed to solve for this too. Now, it's important for you to know this that the formula for solving uh, the change in energy or just basically energy of a photon is just changing E is equal to HV, where this H right here is what you call a Planck's constant. So Planck's constant. And then this V, or what looks like V with a curve on top, is the frequency. Now you're going to be wondering, okay, we're only given the wavelength and Planck constant is a constant, so it has a constant value. And for those of you who don't know, Planck constant value is actually 6.626 times 10 to the power of negative 34 joule seconds. So that is the formula for it. Now we're giving wavelength, we're not giving frequency. Sorry, we're giving wavelength, we're not giving frequency, and we need frequencies to solve this. Now, let's also not forget that in chemistry, in science, you guys did this in some form of physics at some point, or you did this in maybe light chemistry or chemistry that involves you studying photons. But if you have not done it, it's important for you to know this that what connects frequency and wavelength together is the speed of light. So they are inversely proportional in this equation, where the speed of light c is equal to frequency multiplied by wavelength. So this here is just simply wavelength, and both of them are inversely proportional, meaning as the wavelength increases, the frequency decreases, or as the wavelength becomes larger or wider, the frequency will decrease, or as the frequency decreases, the wavelength increases. Basically they are inversely proportional. So what connects them is this c here, which is the speed of light, which is just simply 2.998 or 3.0 times 10 to the power of 8 meter per second. So I'm going to use 2.998 because I want to use as much of the raw value and not approximate as possible. So you have this. So now we have all the information we need in order for us to determine the frequency. So let's not forget, we're doing the first question. The wavelength here is 600 nanometer. So we can rewrite our formula to look like this. So you have change in E is equal to H of V. So that's equal to H multiplied by wavelength. Sorry, H multiplied by frequency. And frequency is simply going to rewrite this one here. Frequency is just going to simply be c divided by wavelength. So speed of light divided by wavelength. So that would be hc divided by wavelength. So yeah, this is it. So the formula becomes changing E is equal to hc divided by wavelength. So yeah, that is the formula we're going to use. You can see how I've combined it from hv to hc divided by lambda. That's how it's done. So now we have the value for wavelength. Let me rewrite it. We have the value for wavelength to be 600 nanometer. Okay. We have the value for Planck's constant to be 6.626 times 10 raised to the power of negative 34 joule per second, or sorry, joule second. And we also have the speed of light to be 2.998 times 10 raised to the power of 8 meter per second. So we can just simply substitute for this first question. So we end up with changing E is equal to 6.626. So we're substituting Planck's constant times 10 raised to the power of negative 34 okay, joule second times 2.998 times 10 to the power of 8 meter per second divided by the lambda, which is 600 nanometer. We know nano is the same thing as times 10 to the power of negative 9 meter. So, of course, we cancel out. You can see how straightforward this is when you actually work on breaking things down. So, you cancel out the seconds, cancel out the meters, and you have change in E is equal to 6.626 times 10 to the power of negative 34 times 2.998 times 10 to the power of 8 divided by 600 times 10 raised to the power of negative 9. So when we input this information in our calculator, so we end up getting 3.31081 times 10 raised to the power of negative 19 joules. And of course, we're scientists. We cannot put our work in what is not the proper number of sig figs. So we're going to go back to the question and see how many sig figs we're given. We see that we're dealing with 600 nanometer. So that is 3 sig figs. So we have to input our work. Sorry, we have to rewrite our work in 3 sig figs. So we end up with the change in energy of the photon, or the energy of photon, becomes 3.31 times 10 raised to the power of negative 19 joules. So this is basically the answer to this question. Yeah, that's it. But let's not forget, we are not done. We were asked to find the energy per mole of photon. So now you're going to be wondering, well, anytime we deal with mole, we have to divide by whatever we have. For example, if we're dealing with molar volume, we go from volume to molar volume, you divide by n to get the molar volume. Usually, anytime we're dealing with anything that requires or to have, say, for example, molar heat capacity will be heat capacity divided by mole. But in this question, we're going to do things a little different. We were asked for the energy per mole of photon, but let's not forget that the way we always like do chemistry in Gen Chem is not always going to be the same way we're going to be doing it all the time, although we build on those foundation knowledge. Here we don't have a mass of photon. We don't, of course, don't have the molar mass for photon because photon is not an element. So we have to use our other knowledge that we learned in general chemistry. Remember, we know that 1 mole of a substance is what 6.022 times 10 raised to the power of 23 particles, moles, whatever you want to call it, is the same thing here. This thing here is what we call Avogadro's number. And with that knowledge, we would know, or we should know, that 1 mole, okay, of photons particle is going to just be 6.022 times 10 raised to the power of 23. And of course, the units for this one, what is to call it, the units for this information here would just be 6.022 times 10 to the power of 23 divided by mole. So the unit for this is just simply 1 over mole, which makes sense because since 1 mole would give you 6.022 times 10 to the power of 26, the units for 6.022 times 10 to the power of 23, sorry, not 26, is going to be 1 over mole. So we have this now. So because of this, and we're told to find the energy per mole, aka joules per mole, we're going to rewrite the equation that the energy per mole so of photon is going to be the energy of photon, which is changing E, multiplied by the Avogadro's number, and A. So yeah, that's how we get energy per mole. So this work here, the unit is going to be joule per mole. So that is how you derive the formula, joule per mole. So yeah, without further ado, let's substitute. So we have energy per mole is equal to change in energy 3.31081 times 10 raised to the power of negative 19 joules. Okay. And I know you'll be wondering, well, didn't we already round up? we don't need to, anytime you're reusing like a value that you already solved for, you're going to use the raw value. You cannot use the approximated value because you want to get your final answer of every single question in the proper raw values as possible, and then you can approximate. So we're using the raw value of what we've calculated for the energy of photons. So times, of course, 6.022 times 10 to the power of 23 per mole. Since it's just 1 mole of photon will give you this. So of course, we multiply, we do our mathematics, we end up with, when we input this in the calculator, we end up with 1.99 times, sorry, 1.9938 times 10 raised to the power of 5 joule per mole. That is how you solve this question. But let's not forget, we are beautiful scientists, so we want to make sure our work is as accurate as possible. We have to remember that the lowest number of sig figs is going to be 3 sig figs, since our initial question was in 3 sig figs anyways. So that would be the energy per mole is equal to 1.99 times 10 raised to the power of 5 joule per mole. So this is basically the answer to this first one, which is the 600 nanometer. Now let's go back. The second we have is 550 nanometer. So we're going to solve for that. 550 nanometer yellow. We have the change in energy or energy of photon to equal hv, which is just Planck's constant times frequency. So that's basically it. So you have the change in energy is equal to Planck's constant times c divided by lambda. So we're just reusing that equation. So we have Planck's constant, we have speed of light value, and of course we have the wavelength. So you just simply substitute. So you end up with Planck's constant. Remember, Planck's constant is 6.626 times 10 to the power of negative 34 joule seconds. And the frequency, sorry, and the wavelength is just simply 550 nanometers. And then the speed of light sees 2.998 times 10 to the power of 8 meter per second. So we're going to substitute all of that here. So you have 6.626 times 10 to the power of negative 34 joule seconds times 2.998 times 10 to the power of 8 meter per second divided by lambda, which is 550 nanometer. So 550 times 10 to the power of negative 9 meters. So cancel out the meters, cancel out the meters, cancel out seconds, and cancel out seconds. So change in energy or energy of photon becomes 6.626 times 10 to the power of negative 34 times 2.998 times 10 to the power of 8 divided by 550 times 10 to the power of negative 9. So when we input all of this information in our calculator, we end up getting 3.6118 times 10 raised to the power of negative 19 joules. Well, of course, we're chemists. We have to put in the lowest number of sig figs. So the lowest number of sig figs is 3 sig figs. So our change in energy or energy of photon, whatever you want to call it, is 3.61 times 10 to the power of negative 19 joules. So this is the answer here. Now, our work is not done. We already know the drill. We're supposed to solve for energy of photons. So, energy of photons, sorry, not energy of photons, energy per mole of photons. So, that would be E mole is equal to the energy of photon multiplied by the Avogadro's number. So, E mole will simply be the energy of photon in this case, or energy of photons is just 3.6118 times 10 to the power of negative 19 times Avogadro's number. Let's not forget the joules, I apologize. So joules, K, times Avogadro's number, which is 6.022 times 10 to the power of 23 per mole. So that's the energy per mole. So energy per mole will just be multiply all of this. You end up getting 2.17503 times 10 raised to the power of 5 joule per mole. So we're going to put this in the proper number of sig figs, which is basically 3 sig figs. So E submole is going to equal 2.18 times 10 raised to the power of 5 joule per mole. So that's basically the answer here. So yeah, that's the answer for this one. Now we have the last question for 100 nanometers. So we have 400 nanometers here. This is the last question for this video. So let's not forget the formula. Let's go to the previous page. Is just energy of photon is equal to hc divided by lambda. So changing E is equal to hc divided by lambda, where we know h Planck constant to be 6.626. And I keep writing all of this constant value because you may have one of those professors that don't give you, and you have to like memorize it to work with it in a test or quiz or an exam. So yeah, so the speed of light is 2.998 times 10 to the power of 8 meter per second. So that's it. And of course, we know what lambda is, our wavelength. We know what that is. So changing E is now equal to 6.626 times 10 to the power of negative 34 joule seconds times 2.998 times 10 to the power of 8 meter per second divided by lambda. So divided by 400. We know nanometers to be times 10 to the power of negative 9 meters. So we cancel out the seconds, cancel out the seconds, cancel out the meters, cancel out the meters. So changing E is just going to be 6.626 times 10 to the power of negative 34 times 2.998 times 10 to the power of 8 divided by 400 times 10 to the power of negative 9. We end up with 4.9662 times 10 raised to the power of negative 19 joules. Yeah, that is basically it. So yeah, that's it. But then again, we're chemists. We have to find the lowest number of sig figs, and the lowest number of sig we're given in this question is 3 sig figs. So we have to basically approximate. So changing E, the energy of photons becomes 4.97 times 10 raised to the power of negative 19 joules. That is basically the answer to this question. Yeah, that is the answer to this question. Now, the energy of mole or E mole, remember, is just simply the energy of photons times Avogadro's number. That's how you get the energy per mole of photon. So E mole is now simply 4.9662. Again, I'm going to use the raw value, not the approximate value, so I can get the right answer, times the Avogadro's number, which is just 6.022 times 10 to the power of 23 divided by mole. So E mole or E submole is equal to 2.99065 times 10 raised to the power of 5 joule per mole. Now, of course, our work is in 3 sig figs, so we're going to put our answer in 3 significant figures. So E of mole ends up becoming 2.99 times 10 raised to the power of 5 joule per mole. So this is basically the answer to this question. So if you have any questions, please, please, and please put it in the comment section. We have successfully done all 3 parts of the question, and I'm really hoping that you guys fully understand. If you don't, make sure you rewatch this video. And if you do, there's another similar question like this I do on my channel. So make sure you watch that one as well. So if you have any suggestions, concerns, questions, please put it in the comment section. I also would like to mention that if you're a student who is struggling in any of your STEM related courses, whether you're in middle school, high school, college, I'm the tutor for you. I help students succeed in all their STEM related courses by my way of tutoring and mentorship through their academic journey. So if you would like to book any of my services, make sure you email me at shuhabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.